Find a formula for Sn for the arithmetic series. 1 plus 2 plus 3 plus 4 plus ... Part 2. Use this formula to evaluate 101 plus 102 plus ... plus 500. So Sn represents the general rule or the general formula, or like the nth term formula for an arithmetic series. So a series is when we have a sequence and we add the terms together. So instead of having commas in between the terms, we have pluses. So this is the formula for an arithmetic series. Sn equals n over 2 multiplied by 2a plus n minus 1 times d. The n represents the number of terms. The a represents the first term. And the d represents the common difference. So in our sequence 1, 2, 3, 4, ... 1 is the first term. So a is equal to 1. The difference between 1 and 2 is going to be 1, or 2 minus 1 is 1. So d is going to be 1, the difference is 1. And we don't know what the n is. We don't know what the number of terms is. What we're trying to do is create a formula that we can use if we know the number of terms to find what they all add up to. So I've got my formula that's given to me in my formula tables, and I just sub in what I know. So I'm going to swap the a for 1, because I got a is equal to 1, because that's the first term. The n stays as it is, and I'm swapping the d for 1 with brackets around it, because we got the d to equal 1. The difference between the terms is 1. 2 multiplied by 1 is 2. N multiplied by 1 is n, and minus 1 multiplied by 1 is minus 1. So then we have n over 2 times 2 plus n minus 1. And n over 2 multiplied by this, well, the n is going to go into the numerator and the 2 stays as the denominator. And whatever we have inside our brackets goes into our numerator as well. So 2 minus 1 is 1, and then we just bring down the n. So here we have a general rule or a general formula known as Sn for this arithmetic series. So part 2, we're going to use this formula to evaluate this. So we're going to use this formula here. So 101 plus 102 plus ... plus 500 is going to equal 1 plus 2 plus ... plus 500 minus 1 plus 2 plus ... plus 100. So where did this 100 come from? Well, the actual sequence that we're interested in starts at 101 and is going up in ones up as far as 500. So what we have inside our first set of brackets is going from 1 to 500. And what we have in our second set of brackets is going from 1 to 100. And we're only interested from 101 to 500. So this minus this will leave us with this. So that's where that 100 came from, because that is the last term before 101, because we're going up in ones. If we had been going up in twos, for example, the last term before 101 would have been 99, and so on. Now, 1 plus 2 plus ... up as far as 500 is the same thing as S500. And 1 plus 2 plus ... up as far as 100 is the same thing as S100. So series 500 minus series 100. So now we are going to use our formula that we had created up here, subbing in 500 and 100. So we swap the n for 500, and then it's going to be 500 plus 1 is 501, and that's all over 2. We bring down the minus. Then we swap the n for 100. That's where that 100 comes from. And then 100 plus 1 is 101, and that's all over 2. So then 500 times 501 divided by 2 is going to be 125,250. Bring down the minus. And 100 times 101 divided by 2 is going to be 5,050. And then this minus this will leave us with this. 120,200. So 101 plus 102 plus 103 plus 104 plus 105 plus 106 dot 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 up as far as 500 altogether leaves us with 120,200.